what is the value of x? So we want to know x, which is this little x right here. Okay. And we are already given a, so this is all just plugging in. So since we know a, which is 5/2, we just plug this thing inside a. So essentially it's times 5/2 equals √2x. So this is what's happening. Okay. Now we just need to multiply them. But if you don't have your square root rules set, if you don't know them, then this might be challenging for you. But when you times a number that is not just the square root, it has a coefficient. You can only times it with the coefficient and not the square root. So 2 times 5/2 is going to be 10√2, not 10√20. I mean, sorry, 4. It can't be 10√4 because you can't multiply the 2 and what's in the square root. Yeah, that goes against the rules. So you're going to do that, and then you're going to have 2x. Well, now what, right? So whenever you see an expression that has only a square root, you can times both sides, not just one side. If you're doing something on one side, you need to apply it to both sides to balance it out, right? If you see these really tedious square roots, then you just square both of them. And that's basically the relationship. So in order to get rid of a square root, you would power it, power 2, because this square root actually has a little 2, invisible 2, and you just want to cancel that out and get rid of the square root, just like that. So what this is going to do is that it's going to get rid of the square root right here. So it's going to be 2x on that side. And then on the left side, it's going to be a little bit tricky, but it is actually going to be 10 squared times, well, since this square root is going to be eliminated, it's going to be times 2, right? And then we just 10 times 10, or 10 squared is 100, times 2 is 2x, or you can say 2 times x, right? Since we already have the 2's, right, the remaining must be x. So therefore, x is 100. Okay. You can technically do 2x equals 200 and just solve for x. You can do that. It's just, why not? It's a constant and it's not going to change. And if you want to double check, you can plug this x right here back inside. So 2 times 5 squared 5 root 2. So that's going to be 10 to 10 root 2 equals 2 times 100 is 200. And if you, it's going to be 2 times 100, right? Inside the square root. And then you can take the 10 out, 100 out, because it's 10 squared. And that's going to be 10 root 2. So it's the same. So we know that our answer is indeed correct. So in this question, what you need to know is the step of plugging in what you are given and applying it to the other equation to get to the answer, which is x in this case. The second thing you need to know is how to eliminate square roots, because they become really tedious in these type of problems. And for example, this one right here, where we tried to get rid of the square root, there was a 10, right? There's an invisible multiplication right here, but you needed to apply it to 10 and the square root. So 10 squared times 2, because the square root is eliminated by the square 2, or the square. And then for the other side, there's only a square root, so it just disappears, or it cancels out, if you want to call it that. And then you get to the answer. So that's the second thing you need to know. And thirdly, when we were checking, right, I kind of just briefly went over it. But in order to get numbers outside the square root, it needs to be a perfect square. So it needs to be like 16, which is 4 times 4, right? So you can take out the 4 out of the square root. But if it's 2, you can't just take that out of the square root, because square root is a number times itself, right? So if it's square root 100, then that's going to be 10, because 100 is 10 times 10. But if it were to be 200, for example, then you can't times something by itself to get to 200. You need to break it apart, as we did, 2 times 100. And then we can take out the 100, making it 10 root 2. So